Hi everyone, how are you doing? Okay, so let's start today with the topic of we will be first solving some questions related to change of basis and linear transformation, and then we will be introducing the similar matrices, right? Topic of similar matrix. Okay, cool. So let's start. Now, this is one question that we had in the last class. How many of you remember? Okay, so this is one question that we had in last class. So this question is saying, let's just redo this question. I mean, there was a misprinting in this question. So let's just redo this question. So this question is saying that you have in this vector space, I mean V, there is a transformation there, which is transforming from V to W. Okay. So from V to W, there is a transformation. And in this V, you have two bases, which is B and C. Okay, B and C, and here you have two bases, which is D and E, right? Now what they're saying is that let's suppose A is a matrix that takes from base C and base D. So A is a matrix that is doing this transformation. Okay, assume that A is a matrix which is doing this transformation. And now they are saying that S with the change of matrix from B to C. So S is a change of matrix from B to C. And then P is a change of matrix from D to E. Okay, this is P. Actually, this is a misprinting here. I mean, misprinting in the sense that if it is E to D, then all of the options were true. But let's just quickly do this again. So this is a change of matrix from B to C. This is a change of matrix from D to E. Now they're asking that what is the linear transformation T relative to B and D? Okay, relative to B and D. So what is the answer? So you want B to D, right? So what you will be doing? I mean, if that is given in base B, and ultimately you want in the base D. So what you will be doing? First you will be multiplying by A, or first you will be multiplying by S. First, you will be multiplying by S, right? So, given a vector which is in base B, you will be multiplying by S. Then this vector is in the base C, right? And then you will say that okay, now from here I can go by A, right? So I will multiplying by A. Now this has been transformed, and now final matrix, sorry, the final vector is in the base D. So AS is the correct one. So that was okay. Now let's just see the second one. So what the second one is saying? Let's just see that. Okay. So the second one is saying the matrix representation of T relative to C and E is. So which means they are saying that if you want to go from C to E, okay, from C to E, if you want to go, if you want to go from C to E, then first you will be going C to A. So A will be leading to C to A, sorry, C to D, and then from D to E, if you want to go, then you need to multiply by what? By P. So PA should be there, but since it is P inverse A, so that's why it was false, right? It was false. Okay. Similarly, is this okay to everyone? What they're saying? That you want to go from C to E. So if you want to go from C to E, this is A into P, right? Similarly, if you want to go from B to E, okay, then it will be S, A, and P. Okay. So from B to C, you will be going first, S multiplication, and then you will be multiplying by A, right? So which means that now you are in D and then B. So PAS should be the answer. But it is P inverse AS, so that is why it is also false. Okay. So actually, that was a misprinting. Like this P is a matrix. This P is a matrix which I was saying that is from D to E, but that was actually misprinting. Okay. This P is a matrix actually from E to D. Okay. P is a matrix from E to D. Right. If P is a matrix from E to D, suppose. Okay. Let's just do one thing. Let's just say this is E to D. Okay. Which means let's suppose this P is a matrix from E to D. Now this is basically correct. I mean, all the options are correct. You can quickly verify. Okay. Do you want to verify? Let's just see. See here, from in this V, you have two bases, which is B and C, and in this W, you have two bases, D and E. Now P is a matrix which is going from E to D. This is P. Okay. So in that case, what will happen? And S is a matrix which is going from here to here, and then A is a matrix which is going from here to here, right? Okay. S is a matrix from B to C. P is a matrix from E to D, right? Now tell me, are these options correct? I think now it will be correct. Okay. If you want to go from B to D, if you want to go from B to D, then first you will multiplying by S, then you will multiplying by A, right? If you want to go from C to E, then first you will multiplying by A, and then C to E you want to go, right? If you want to go to E, then P inverse, right? So P inverse A. If you want to go from B to E, then first you multiply by S, then you multiply by A, then you multiply by P inverse, right? Is this okay to everyone? Okay, okay. In that case, all are true. Okay. So this is changed from previous slide, right? So that later on you don't get confused that how it is E to E D. This is changed question. You consider this a changed question. Okay. Okay. Now let's solve more questions. Let's solve this question, which is very nice question. So what they are saying that suppose, do you remember the linear transformation from the last class, from any arbitrary basis to any other arbitrary basis? Let's suppose a linear transformation T, the standard matrix, okay, is let's suppose A. This is let's suppose a standard matrix. Now, suppose you want a matrix, right? Some matrix M, which we also represent like this, right? Let's suppose this is going from B1 to B2. Okay, suppose we want some matrix which does the transformation but takes from B1 and gives to B2. Then what is this M? Can anyone tell me? Yeah, this is B2 inverse, B2 inverse A B1, right? Also, which is same as, you can say, uh, transformation of the input basis. Let's suppose this is B1. Okay, so the input basis is B1, B2, right? Is this correct? Is this same as this? Tell me quickly. No, right? So here it will be with respect to B2, right? Or if you want, you can write it something like this, which is same as T of B1 is nothing but A B1, right? A B1 with respect to B2, and then A B2 with respect to B2, right? Okay. Let me know if that is fine, right? Is this okay to everyone? Okay, okay. So basically, let me just tell you one small thing. Suppose, I mean, you already might be knowing this, but suppose you multiply two matrices, right? Suppose you multiply two matrices, any random matrix. Suppose we multiply two matrices, A and B, okay? Or maybe you can take any other name. Can you suggest me some good alphabets for the matrices? M1, M2? Is M1, M2 good for you? Okay, M1, M2. So let's suppose you are multiplying M1, M2. Now, suppose that you have something like this, okay? In M1, and as you already know that let's suppose this is M1, this is M2, right? This is M2. Then after multiplication, what you will be getting? You will be getting some matrix. Can you tell me how each of the column of this matrix behave? This column will be the linear combination of the columns of M1 or columns of M2. Tell me. Yes, columns of M1, right? So actually, let's suppose this is some vector. Let's suppose B1, this is B2, right? Like this. So can anyone tell me if it is a linear combination of columns of M1, in that case, where the coefficients will be coming? I mean, let's suppose this is a linear combination of first column, second column, third column, but to take the linear combination, you have to have the coefficients, right? You will be multiplying something here, something here, something here. So it will be coming from B1 or it will be coming from B2. Yes. So Aditya is saying that it will be coming from B1. Yeah, that is correct, right? So basically this column is nothing but MV1. Do you M1 V1? Do you agree with me? The second column will be same as M2 V2. Sorry, M1 V2. See, this first column is nothing but this matrix linear combination, right? And the coefficients will be coming from this. So isn't M1 V1 the same thing that I'm saying? Tell me, isn't M1 V1 the same thing? Let me know if that is okay, right? So this M1, or if you want, you can understand like this. See, if there are two matrices, right? If there are two matrices, let's suppose A and let's suppose B. Okay. Let's suppose this B is having V1, V2, V3, right? This is A. If you multiply A, I'm not opening up this A. Okay. Suppose I'm not opening up this A. Then the final matrix want it to be AV1, AV2, AV3, something like this. Tell me, is this okay to everyone? You just consider this as a scalar for now. Want it to get multiplied to each of the column or each of the row, right? Consider if it is a scalar, want it to be multiplied with each of this. If it is a scalar, it will get multiplied, right? So just for the sake of understanding, you just understand like this, that if you're multiplying two matrices, then you can visualize these two matrix multiplication like this also, right? It is just a way to visualize. How many of you agree with this, that this is okay to you? How many of you say that okay, this is okay to me? Okay, so Aditya is saying this is fine. Ajay, Harsh, okay, Kapish saying this is fine. Okay, great. This is fine, right? This is a way to visualize two matrix multiplication, right? This is a way to visualize. What is the spelling of visualization? Uh, Matrix. ठीक है. Okay. So I hope you guys understood this, right? So this is a way to visualize the matrix multiplication. Okay. ठीक है. So now, if you agree with this, then we can talk about this thing that I was just talking about. I think here, right? ठीक है. So till now it is fine that this thing and this thing both are same. Till now this fine. I mean, either you calculate like this or you calculate like this. Is this fine? I mean, we have done yesterday. We have done many examples, including questions from MIT and many other resources, right? So there are two ways, right? One of them is this, or another one is this. Today, I just want to make you realize that both are actually same. Okay, I mean, this is actually same. So let's just check whether it is same or it is different. Okay, so maybe I can just keep it. Now you tell me, if you want to convert, okay, if you want to convert, let's suppose something from standard basis to B2, then what you will be doing? So can you, what I mean to say, can you say, can you just write it, this particular term or this particular matrix as something like this? This is nothing but b2 inverse tb1 and tb2. Is this okay to you guys? Basically, this is in the standard basis, right? I mean, transformation always in the standard basis, right? So this vector is in the standard basis, this is in the standard basis. Now if you want to convert something from standard basis to b2, want to be multiplying b2 inverse, right? See, if that is in already in b2, you want to convert that to standard basis, what you will be doing? You will be multiplying by b2 and then you will be getting in the standard basis. But if it is already in the standard basis, want to be multiplying b2 inverse like this, right? So we know that if something is in the standard basis, then we can multiply b2 inverse like this. So basically, if that is in the b2, oh, I mean, if you want to represent these things in the basis of b2, it is same as saying b2 inverse this, right? This is in the standard basis, and then you multiply it by the b2 inverse. Then basically you can think like this. I mean, from here to here, at least it should be fine. If it is a b2 inverse into this, then it is nothing but representing this in the b2, representing this in the b2, right? From here to here, I think it should be fine. I mean, if you can't think in the reverse way, then at least this way should be fine, right? I mean, see, it is just that till now we have been doing with just one vector. Okay, we have been doing like this, b2 inverse x. Now I'm just showing multiple vectors at a time. Okay, so I'm just showing instead of just saying that b2 inverse. Okay, if you want, I can just break it, but I thought that you can just catch it with just a second. Let me go to the next page. So if you want, I can just write it in two steps. See, at least it should be fine that if it is in B2, then it is nothing but if x of B2 is nothing but x into B2 inverse. Is this fine to everyone? So can you write like this? This is nothing but B2 inverse into T of B1 and then B2 inverse into T of B2, right? Is this okay? See, this vector, this is just a vector, right? Any vector in B2, you can write B2 inverse x, B2 inverse this, that particular vector, right? Now you're taking B2 inverse common. Okay. So from here to here, is this fine now? Cool. Now from here, you can say this is nothing but B2 inverse AB1. I mean, TB1 is nothing but AB1 and then AB2. Is this okay? Okay. Now from here, it is just a B2 inverse, and then you can do one thing. Uh, this is basically, you can treat it like you can take this A common again, right? And then it is B1 B2, which is nothing but B1. It is finally B1. So actually, this and this matrix are same. Can you can you now try to visualize that these two matrices are same, right? So basically, this matrix is saying you're converting to B2, right? So let me quickly do this again. This matrix is saying you're converting to B2, which is same as saying you're multiplying by B2 inverse, right? And then this is T of B1, T of B2, right? And then since it is T of B1, it is actually same as A of B1. So since it is A of B1, it is A of B2. Can't I take A common? Sorry, B2 inverse is already there. Then A, it is B1, B2. And then from here, it is easy to see that this particular thing is nothing but B1, right? I mean, that is my notation. So this is nothing but B1. Is this fine to everyone? Okay. So the matrix that we have got earlier, okay, B2 inverse A B1 and this particular thing, actually both are same, right? So this is just a small, I can say, demonstration to show you that actually both matrices are same, right? Okay. So if I'm talking about like this, then let's just let's just go to one thing. Okay, let's just talk about change of matrix, change of base basis matrix here itself. Do you remember change of basis matrices? If let's suppose you're changing from from let's suppose it is B1 basis, okay, B1 basis, and this is B2 basis. Let's suppose you're changing from standard basis to B1 basis. X in the standard basis, and you want to change to B1 basis. What you will do? What you will do? You will, if you want to go from, if you want to go from here to here, B1 inverse or B1? Yes, you will be multiplying by B1 inverse. That's great. So you will multiplying by B1 inverse. Similarly, similarly, if you want to go from here to here, it is always opposite. Okay, you will be multiplying by B1, right? Now, now similarly, let me write like this: that if you have X of B2 here, and if you want to go from here to here, from a standard basis to something, then from a standard basis to B2, then it will be, I think, B2 inverse, right? So it will be B2 inverse. And from here to here, it will be B2. Now, I'm just asking from B1 to B2 you want to go. So what is the matrix you will be doing? If it is in already in B1, then you will first multiplying by B1, right? If X is already in B1, first multiplying by B1, you will go here. Then you will go to here, right? B2 inverse. You will multiply by B2 inverse. Is this fine? And then finally, this particular thing is nothing but X is in B2. Let me know if that is fine. How many of you agree that that's okay? Okay, right? So this is the change of basis matrix. Now let me just claim one thing, and now you can try to see that both the things are same. Okay. So my claim is, let me just claim one thing, which is this. So now here I'm just claiming one thing. Okay, before I go further, tell me, is this too mathematical? I mean, we have spent, I think, 3, 4 lectures in just linear transformation, change of basis. Is this too mathematical? Yes, actually, it is mathematical. I won't be able to deny with that. But is this too much to understand? Or I mean, you are little bit digesting. See, when it comes to machine learning तो easy हो जाएगा. Don't worry. जब ये एक बार को समझ में आ गया, then you will be able to connect the dots. Okay. And and for me, actually, let me tell you, my personal expertise is in machine learning, which means that like, I mean, I have studied machine learning syllabus multiple times, that too in too good depth. Okay, so it is too much enjoyable for me also. I mean, when we come to machine learning, it will be very very easy, very very comfortable. But I'm just asking this linear algebra part. Don't try to project that, okay, if linear algebra is this much, then machine learning will be too much. It's not like that. Okay, it need not to be like that. So it doesn't mean that machine learning will be too much mathematical heavy. I will make it very very easy. But just for now, just see if it is too much to understand. I think with some practice, it will be good, right? After solving some quiz and some practice questions that I'm going to upload, after that, I think it will be good. Okay. Now, this is the change of basis matrix that we have got. What is the change of basis matrix? Let's just call uh let's just call this matrix as M B1 arrow B2. Okay, which means it is changing from B1 to B2. And what is this matrix? This matrix is B2 inverse B1. Okay. Now my claim is that this B2 inverse B1 is nothing but this matrix. Let's just see what I'm going to write. This is basically So you can say the coordinates of this b1 is a basis vector. So again, my notation that I have been following till now is this, right? As you know, this is b1, this is b2. This matrix is b1 vector with respect to basis b2. Again, the basis vector b2 with respect to b2. Okay. So let's just see if my claim that I'm claiming is these two are same. Okay. Are these two same? Which means this particular thing is the same as is the same as b2 inverse b1. Okay. Which means this particular thing that I'm claiming is actually a change of basis matrix. It is a change of basis matrix which is changing from b1 to b2. Let's just check whether this is same. Can you check whether this is same? Is it too hard to check? Let me know. How many of you are able to visualize that these two are actually same? Just take your time and let me know. If you're done with the visualization that or maybe the calculation, then you can just let me know. You can just say done. Okay. There is nothing related to transformation here. Let's not worry about the transformation. We are not doing any transformation, let's suppose. Okay. So yeah, Kapis is saying done. Aditya is saying it's fine, done. Okay, great. So see here that that this b1 with respect to b2, okay, is nothing but b2 inverse b1, right? So this is my claim, by the way, right? And I want to prove this claim, right? Claim is that the change of basis matrix is this, right? Which is same as this. Now I want to prove this, right? So let's just try proving this. Okay, let's just see if we are able to prove it successfully. So this is this LHS part. Let me write the LHS part. This is nothing but, as you can see easily, this LHS part is nothing but, you can say B2 inverse, B2 inverse, B1. This is B2 inverse, B2. Is this fine to everyone? I mean, if you're representing any vector X in any basis, you can always write it that particular vector X into B inverse, right? I mean, a standard basis. Is this fine? So basically, if you're representing in B2, then this is same as this. Okay. So for any vector and for any basis, I hope that's fine. Now you can take this B2 inverse common, and which is same as B2 inverse B1, isn't it? That's very easy to see. Or maybe you can see that this B1 is also, you take it as like, I mean, take it just like vectors, right? Okay. I mean, don't worry that whether it is a basis vector or something. Can you say that this B1, whatever this B1 is, see this particular B1, okay, just a second. Let me probably remove it. Can you say this B1, whatever this B1 is, it is basically having B1 and B2. I mean, two vectors. Let's suppose B1, B2, right? And now, let's not worry about that this vector is a basis vector or what, but it is this vector. It just, coordinate in the standard basis. I mean, these are the coordinates, right? Which you can always treat as a standard basis. Now, if you're multiplying by B2 inverse, isn't it same as this? Which means this vector representation in B2, this vector representation in B2, right? So what I mean to say, let me just summarize everything. Okay, let me just summarize everything. See, if there is a transformation matrix that is transforming from B1 to B2, then it is same as, okay, let me write it, B2 inverse B1 and A, where A is a standard matrix, which is same as, which is same as A is a standard matrix, and then, uh, yeah. So basically, you can say which is same as transformation of. Sorry, is this no no? Sorry about it. So I made a mistake. Yeah. So this is same as, you can say A into B1. A into B1 is nothing but transformation of B1 vectors, right? I mean transformation of this basis vectors. And then once you do the transformation, then if you're multiplying by B2, once you do the transformation and then later on if you're multiplying by B2, then what does this mean? B2 inverse, then what does this mean? It means that you are doing the, it means that you are doing the basis change, right? So this particular thing and this thing is same basically. Now if you're doing B2 inverse also, then if you're doing B2 inverse also, then this whole thing, right? This whole thing is same as, so you can say, uh, let me just use the arrow. So basically this particular thing is this. Now this whole thing is same as this thing, right? You can multiply, you can have the in terms of B2. Okay. Are these two okay to everyone? That this particular matrix and this particular matrix that we have, both are actually same. AB1 is nothing but transformation of B1 vectors when B2 vector, and then B2 inverse is nothing but having, I mean, changing their bases, right? Okay. Hope that's fine. Now, now, let's just summarize the second thing that we had today, which is change of basis matrix, right? Okay. So this is a transformation matrix, but let's just have change of basis matrix, which is not doing the transformation. It is just changing the basis from B1 to B2. So what is the difference between this matrix and the matrix that I'm going to write? The difference will be that this matrix is saying that you change the basis. Sorry, you are in B1, you do the transformation, and then you change the basis also. So basically you're doing the transformation, but here you're not doing the transformation, just this. So what was that matrix? Let's just represent it like this, okay? What was that matrix? It was B2 inverse B1. Do you remember? It was B2 inverse B1, right? And I also claimed that it is nothing but you can say this is B1, right? You consider, I mean, there is no transformation here. You just consider like just a vectors. So there is no transformation, okay? If there is no transformation here, then it is nothing but changing the basis of the B1 vectors. I mean, so the B1 vector you have, but you're changing the basis of B1 and then you're writing B2. Are these two matrices fine? In fact, if TB1 is same as B1, okay, if TB2 is same as B2, if TB1 is same as B1, which means TX is X, okay, TX is X. If TX is X, in that case, this A will be identity matrix. I mean, there is no transformation basically, okay. In that case, the transformation is bound to be anything, and this change of basis and transformation will be same. So, and anyway, let's not even try to get confused. But yeah, is this fine that you are writing this B2 inverse B1 that we have got from the previous class? It is nothing but B1 B1, you're changing the basis of B1 and B2, right? In terms of B2. So you always take the input basis, always take the input basis that we start with. And then if there is a transformation, you transform it. And then after transformation, you change the basis, right? If there is a no transformation, then you directly change the basis, right? You always start from B1. You always start from B1. If there is a transformation, you transform and then B2. If there is no transformation, you directly write B2. Okay. Now we will do few questions, and after that, this whole of the idea, okay, will be more clear. And why I'm more interested in these notations, it will also get clear. I mean, see, these two notations are good, but sometimes I'm even interested, okay, just to solve the questions quickly, I'm interested in these notations. You will get to know why I'm more interested in these notations. For example, if I just reveal the suspense to you, then let's see this example here. Okay, let's see this example. This example or this question that I've taken from some standard university, okay, Dartmouth. So what they're saying, that you are having two basis vectors, okay, B1, sorry, B and C, two bases you have. And now what they're saying, let's suppose they're saying that you want to basically change the basis from B to C. Okay. So let me, let me probably just, copy only this much, and let me just show you what they're saying. See, let's suppose there are two bases. Okay. The bases are B and C. Let's suppose there are two bases. Now, in these two bases, what they are saying, you want to change from B to C. This is the idea. Okay. You want to change from B to C. So uh, what is the matrix that will be changing from B to C? I think as per the matrix, right? As per the matrix, what is the matrix that will changing from B to C? C inverse B, isn't it? It will be changing from B to C. Is this fine to everyone? If the X is in B, if X is in B, then C inverse B is a matrix which will be changing from B to C. Let me know if that is fine. Because this will be the standard representation, and then finally you get C inverse, right? So C inverse B is some matrix that they're interested in. Okay. I mean, they're interested in finding C inverse B, something like that, right? Okay. Now they have given some relationship between these two basis vectors. Now, as I know, the C inverse B is nothing but the first basis vector B1. C inverse B that you are interested in finding, right? This is B2, this is B. I've just written B and then C inverse, right? B into C inverse. Now, if you multiply with C inverse, isn't it same as saying that you're changing the basis to C? Isn't it same as saying this? Let me know, right? Both are same. So now can you tell me what will the representation of B1 with respect to C? It is easy to see from here. Can you tell me? Yes, see, Aditya has given the correct answer, which is 1 and minus 3, right? 1 and minus 3. So 1 and minus 3 will be there, isn't it? So this matrix is 1 and minus 3, and then minus 2 and 4. That's all, right? That's all. So they are interested in finding the matrix C inverse B, and they have given the relationship between B and C, something like that. Then it is just like, I mean, the coordinates of B1 with respect to C and coordinates of B2 with respect to C, isn't it? There was one homework question that I've given in the last to last class, I guess, in one of the class actually. Uh, yeah, this is the question. Has anyone gone through this question? Right. So have you people, have anyone gone through? Now you just try out this question. This question is from, last to last class, but we haven't solved it. Now you can try out this question, right? Okay. Now, do you think that this representation that we are talking about, for example, t v1 input basis is v1, always okay. If there is no transformation, don't write this t, just like b1, right? b1. Always write the input basis, okay, with respect to the output basis. So, what is the output basis? Output basis is here. Let's suppose it is w, it is v. Okay, output basis is w. Do you think that this kind of representation is useful? I think this is useful, right? Okay. If you want to solve this question, I think you can easily solve if you know this, that the change of matrix is nothing but this, which is, can anyone tell me, which is same as in terms of, compact form? What is the C, I mean, W inverse V, V inverse W, V W, what is this matrix? The change of matrix that I'm looking for. This is W inverse. Yes, this is W inverse V, right? This is W inverse V. Okay. So basically this kind of, interpretation that that we have figured out is actually important. That's why I'm telling you these two interpretation. We have yesterday seen that these two are there, but we have not, conveyed the idea, because I first want you to have the practice. That's why we have not conveyed the idea that why these two are same. And now we know that why these two are same, right? And now we also know that why these two are also same. Okay, cool. So I hope you understood a little bit here, right? Now we will do multiple examples, including the examples where you will be needing this support. Okay, you will be needing this support in the sense that they will give you something that if you know this kind of interpretation, then you will be doing that. And obviously, if you know this kind of interpretation, then it will be very helpful. So let's do examples now, where both of these interpretations will be very helpful. And just mark this slide. This is very important. Okay, this is very important slide, I can say. This is summarizing everything that we have been studying in linear transformation and in basis, change of basis matrix. Okay, now you know what is a linear transformation representation, what is a change of basis representation. I mean, if you are doing the transformation, then you do the transformation of the basis vector input basis. If you're not doing the transformation, then directly write it. Okay. Or in other words, if age identity, or in other words, if tx is just x, okay, it is not doing anything. This is just b1, this is just b2, then both are actually same. Now probably it's time to do some more examples, and then you will get to understand more, right? Let's just start with this example. Okay. Now what they're saying, okay, before I start with this example, let's suppose they also ask you in this particular question, they say b2c. B2C you can find out very easily. How? Input basis, and input basis is already there, right? Let's suppose if they ask you to find out C to B, then what you will do? So one idea is that you find out value of C1 and value of C2. Okay, value of C1 and value of C2 in terms of B1 and B2, which is okay. I mean, you can find out the value of C1 and C2 in terms of B1 B2, which is okay. But if they have already given this something like this, then what you can do? You can do this as Aditya is also saying. Then if you want C to B, then you can take the inverse of this, right? Let's suppose this is M. Okay, M is taking you from here to here. If M is straightforward, you find out M, and then you can take the inverse, right? You can take the inverse of M. Then you can go from C to B also. Okay. So whatever, okay, if B2C is straightforward in the sense if they have given some relation like this, then B2C is straightforward. Then you find out this, and then you can take the inverse. Whatever is very convenient to you, you find out that, and then you take the inverse if they ask you to find out the reverse of that, right? Okay. Okay. So let's do more examples. Probably it will be more clear. Now, let's try to understand what they're asking in this particular question. This question I have taken from this university. So consider the linear transformation defined by this, right? Then they are asking find the matrix representation U with respect to the basis V. Find the matrix representing L with respect to basis U. So basically, they are saying that you do the transformation of basis vectors, and then ultimately, you want with respect to U only. Okay, transformation is defined like L. Ultimately, you want with respect to U only. So can you do this? Is this understood that what they're asking? Okay. So what is the answer here? So you can find out L of U1, because with respect to, if there is only one basis, then it means their input and output basis is same. Okay. This is nothing but 2 minus 1, 1 and 3, right? Yes. So everyone of you have given the correct answer. Let me, write your answers here. Okay. So I hope that's fine to everyone. Now let's just move to the next question, what they're asking, right? Let's just move to the next question. So in the next question, they're asking something like this. What they're saying, find the matrix which do the transformation with respect to the basis B. Okay. Instead of finding with respect to basis U, which we have just done it, now with respect to basis V, they're asking. So ultimately, they want to say that let's suppose this is basis U, right? In R2 itself, let's suppose you are doing some transformation. Okay, from U to U, there is a transformation, which is uh, what is that matrix? Uh, let's just call it. We can call it M, right? Okay, MU. Okay, I mean whatever you like to call it. I mean, see, the standard notation is this. Okay, maybe I can call it like this. So maybe, so this is, let's take it LU. Is this fine? That LU you have just computed. Okay, what is this LU that you have just computed? It is it is minus, sorry, it is 2 minus 1, 1 and 3. That is what we have just computed. But they are not interested in this. In the next question. In the next question, they are saying that we are more interested in finding, okay, we are more interested in finding uh, from V to V, right? From V to V. They are more interested in this. So what you can do, can you tell me what you can do? First, you can change the basis, right? First, you can change the basis from V to U. So if X is in V, then which matrix can change the basis from V to U? Output is U. So whatever is output, so basically, or maybe you can think like this. This will be standard, and then it will be the matrix, right? Okay. So this is something. This is a vector that you have just got in basis U, right? Now you can do the linear transformation. Okay. Now you can do the linear transformation. And then again, this is in basis U. This is what in basis U. Then again, what you can do? Now which matrix I should multiply such that I get in basis V? It will be V inverse U this time, right? V inverse U. Okay. So what is the final answer? Final answer is this, right? This is a matrix which will take from V, V, convert to U, taking the help of U, LU, then convert to V. Okay. This is a matrix which is ultimately taking from V and then doing the transformation in V. Okay. Isn't it? Let me know if that's okay to everyone. Right? Yes, you need to calculate. No, you need to calculate U inverse, and then you need to also calculate V inverse. And then, okay, you don't need to, I think, calculate V inverse. You just calculate U inverse, multiply, then these are inverse of each other. Okay, let's just check. Let's just check. Okay, first let me repeat what did I say, or maybe let me check that what method they have used. I mean, this is just one of the method which is coming to my mind. Let's just check what method they have used. Okay. So this is what I'm saying is the final answer. So it seems like I think they have also used the same thing. So they are saying this AL, okay? They are saying this AL, I think, because from the last example, this is the AL, right? Which we are representing LU. Okay. So this is AL they are saying. Yeah, from S U inverse V. So they are multiplying U inverse V and S inverse. Yeah, they are doing the same thing, right? S is U inverse V, which is they are saying this is S, this is S inverse. So they are saying the final answer is S inverse ALS. Yeah. So they are also doing the same thing. So actually, I mean, you can understand from here that what I'm trying to say, see, you have R2, R2, vector spaces are R2, R2. Here, you have a transformation from basis U to basis U. What is this transformation? What is the name of this transformation? Maybe LU, right? LU. We have computed it, right? We have computed it here. LU we have computed it, right? Which means the transforming with respect to basis U. We know LU we know, right? LU they have given. You people also answered LU. Okay, if input and output basis both are same, then LU is nothing but a representation of this LU1 with respect to U itself. So which means this is 2 minus 1 and 1 3, right? This is what you people have also given me. So this is something that we have calculated in part A. Okay. Now they are more, they are, I mean, in the part B, they are interested in this. They are interested in this long journey. Okay. Now, if you have, let's call it, let's call this matrix S. Then can you tell me what will this matrix? S inverse, isn't it? I mean, R2, V2U and U2 V will be S inverse. Then, then what is the final answer? First S, right? First S. Should I write LU here or here? Tell me. Left or right? LU will be in the left or right? You are more interested in this, right? Then first S, then always in left. Yes, Aditya is saying left. Because this is basically X in V, right? If X is in V, then S will convert to U. So this is X is in U, right? X is in U. This whole thing is X is in U. And then this X is in U. Basically, this LU will be taking the input like this, right? So LU, you will be multiplying this and then S inverse. So the final answer is this. Now, what is the value of S? If you want to go from V to U, what is the output? Output is U inverse. I mean U. So U inverse and V, right? This is the value of S. Is this okay to everyone? Let me know. Right? So basically, we have taken the help of this, right? We have taken the help of this. Can there be other way? Can there be the other way? Any other way? Can you think of? Is any other way coming to your mind? So this is the question. In this question, any other way for this particular part? See, they are asking, the ultimate thing that they're asking is this, right? L V1 with respect to V1 V. Okay. So L V2 with respect to V. So ultimately they're asking this only. Any other way, anyone? Anything, random, whatever. It should be just little logical. Other than that, it could be anything. Okay, long way, short way, whatever is coming to your mind. Okay, so maybe we can do. We want LV1, right? So how to find out LV1? That is the first challenge. So we have LU1 and LU2. Can you represent this V1 vector 1 1? Okay, in terms of U1 U2? Then I will be taking L both side, right? Then I will take L both sides. So L V1 I can find out. Okay. If you do something like this, right? Okay. Just tell me, can you write this V1 in terms of U1, U2? Okay. So what it will be, I think it is 1 1, which is something minus 2 1 and 2 3. 2 minus 3. You want 1 and 1. Okay. If you want 1, if I multiply minus 1 here, तो ये 2 हो जाएगा, 2 और 2 4, है ना? और फिर मैं डिवाइड कर दूं 4 का, इन दोनों को ऐड करके, दिस इज 4, दिस विल बी माइनस 4. ओके, 4 एंड माइनस 4 आ रहा है. हम्म. Yeah, maybe we can solve this equation. -5/4 and -3/4. Let's just, u इनवर्स कितना है? So basically it is nothing but u inverse into v1, right? Yeah, -5/4, -5 and -3. And -5/4 and -3/4. Okay. Okay. So anyway, either you do it manually or you just find the inverse or anything. So it will be -5/4 and -3/4. ठीक है, मतलब you guys can do this if you want to. Otherwise, that's okay. So it is -5/4. This is -3/4. Okay. So now we have V1 in terms of U1 and U2. Now you can take L of V1, right? L of V1 now it is EG. And then whatever you get, it will actually the similar kind of computation. Whatever you get, you again need to, multiply by V inverse to convert that to in the V. Okay. So Himanshu is saying, sir, I can't see the screen. It is blank. So Himanshu, are you on the Zoom or you are using the website? Okay, maybe you need to give permission to the Google Chrome or something, or meanwhile you can use Zoom. So you can go to the link in the Telegram group and then you can use Zoom for this, right? Okay. So basically you can do this. Okay, you people can do this. That how to calculate these two things, right? Or maybe you can go by this method, right? Okay. Okay. Great. Let me know if there is any doubt to anyone. Okay. Okay. So let's now move to the next question. So let's just see this question. What they're saying. Suppose LU1 and LU2 are given like this. Find the matrix representing L with respect to the standard basis. So in this question, they are saying that with respect to standard basis, they are looking for. Okay. So with respect to standard basis is nothing but L of. Okay. You just tell me. You just tell me the answer. Will it be like this? Are they asking this? Are they asking this? Or they are asking this? No, they are not asking L of U1, U2. With respect to standard basis, actually, it should be even E2, right? They're asking even E2, which is 1, 0, and 0, 1. They're asking even E2. So I think it is easier to transform with respect to U first, right? With respect to U, can you tell me what is the transformation? It will be L of U1 with respect to U, L of U2 with respect to U, right? With respect to U, can you tell me the transformation? What it will be? 2 and U, there is no term of U2, so you can say this is 2 and 0, 0 and -4, right? This is with respect to U, isn't it? But they're not asking this. They're asking with respect to the standard basis. Okay. So, which means if let's suppose this is R2, this is also R2. Okay. The transformation that we have in our hand is from U to U. This is the transformation that we have in our hand, which is U to U. Okay. Now, let's suppose standard basis I'm representing by S. Okay. What is a good representation of standard basis? Maybe E. Okay. Or B. Okay. You can do anything. Maybe let's just take it as S. Okay. So they're more interested in S to S journey. So again, you need to do the same thing. So if you want to convert from S to U, then what you will be multiplying? S inverse, right? Or U inverse? Tell me. It will be U inverse. Okay. So it will be U inverse. And then this matrix, the transformation, and then U to S, it will be U, right? So they're more interested in actually this matrix, right? This should be the answer. So let's just check. Yeah, U inverse A U. Okay. Understood? Let me know how many of you have understood and how many of you have not understood. Okay. Okay. So now I think you are comfortable that how to do the linear transformation, how to do the change of basis and these things, right? Now let's just solve more questions and you probably you will be even more comfortable. So let's just see this true false question, what they're trying to say. Let A be the matrix representation of linear transformation relative to B if S is a change of basis from C to B. So they are saying relative to B. Okay, from V to B is a vector space relative to B. So here you have B as a basis, here you have B as a basis, and then from B to B, okay, you are doing using A. S is a change of matrix from C to B. From C to B, if you want to go, you will go from S. Similarly, if you want to go B to C, let's suppose you will go using S inverse, right? Then the matrix representation of T relative to C, relative to C you want to go. So what it should be? Should it be this or should it be this? Just tell me, this is true or false? Just think about it. Aditya, can you think more? Just see, maybe you're doing some silly mistake. So yeah, this given statement is true. Okay. Why that is true? Let me just tell you. See, the given statement is actually true. So if you want to go from this C to C in this long journey, if you want to go, first you will be converting, okay, whatever the vector you have, okay, that should be in the C, by the way, right? First you will be converting to B using the multiplication of C. Then this is in basis B. Then you will be doing the transformation. Sorry, this is S. Okay, S is a matrix. Then it will be in the B. The whole thing is in the B. Then you will be doing the transformation. And then from B to C you want to go, then you can multiply by the S inverse, right? So S inverse AS is covering the whole journey. Okay, cool. Yeah, this was a nice question, isn't it? This was a nice question. So this is this is true. Okay, cool. Now let's solve this question. This is also nice and interesting question. Let's just try to solve this question. So they have given two different bases as B and B prime. Find the change of coordinate matrix Q, change of basis matrix only they're asking. Changes B prime into B. Okay, so from B prime, they want to go to B. Then what it should be? Whatever the output, I think output inverse and then B prime. Yeah, B inverse into B prime. Yes, that's true. Okay, great. So you people have given, I think, the correct answer. Let me go to the next page and remove this answer from here because I want the answer in the next page. Okay, so this is the correct answer. Great. Now let's just solve this question B. What they're saying, there's a transformation, and let this be the case. So do you know this representation? How many of you are comfortable with this representation? Is this a matrix? This is a vector. What is this? This can anyone describe me in words? What is this? Can anyone describe me in the words? This is transformation with respect to, yeah, matrix beta to beta. Great. Yeah. So basically, as I told you, this is if this is beta to beta or something like this, then generally I mean write it in the shortcut form, which is this, right? So this is a transformation from beta to beta. Now they're more interested in the transformation from beta inverse to beta inverse. Okay. Let's just see if you can calculate this. Just try your best. Let me know in terms of A, in terms of A, in terms of beta, in terms of beta prime. These three quantities you can use, and just let me know what is the answer that you people are getting. So this is see, from beta to beta is A. Now they want beta prime to beta prime, right? Okay. So from beta prime to beta you will go. So let's just assume that from beta prime, okay, is a matrix. Q is a matrix that changes from beta prime. So let's suppose this is Q. Let's suppose this is Q inverse. So this is Q A Q inverse, right? Q A Q inverse. Okay. So I mean, I'm reading left to right. So sorry, right to left. I'm reading Q A Q inverse. But if you read left to right, it might be the confusion in the. So don't do these silly mistakes that you are writing. You are in your mind you are saying Q A Q inverse and you're writing correctly. But options, if you're seeing that okay Q A Q inverse, don't mark this option. Okay, just be careful. Okay. I mean, while I'm writing, I'm reading right to left. But in the options, obviously you need to read left to right. So don't mark this as a correct option. This is a wrong option. QAQ inverse is a wrong option. Okay. So basically Q inverse AQ is the correct answer. So let's just see. Okay. Q is coming out to be this anyway. So Q inverse AQ is the correct answer, right? Yes. Okay. We have not calculated this Q. That's fine. But yeah, Q is this and Q inverse AQ is like this. Okay, let's solve this. I think we done it. Okay, mostly we done it. We done for this part. And if you're asking the reverse part, then you take the inverse. So you can we have done it, but still let me just write it as a homework. The solution is on the next page. Okay, for this, the solution is on the next page. Still I'm giving you as a homework. Okay, so let's just see if it is true or false. Tell me. So what they're saying, if C, if you want to go from B to this matrix is changing from B to C, okay? This matrix is B to C. Then it is nothing but this. Yeah, nice. So everyone given the correct answer. This is actually false, right? Why this is false? Let's just see. See, if you want to go, okay, I'm writing from left to right, okay? If you want to go from B to C, then you need to write input vector, okay? Input vector. What is the input vector? B1. B1 in terms of C and B2 in terms of C, right? This is the correct answer. This is correct. And this whole thing, this is basically you can say false, right? So let's just see the answer. False, right? So what they're saying, okay, it's this, right? This is correct. Input basis in terms of the output basis, this is correct, but this is false. Okay, cool. This is actually false. Is this understood? How many of you have not understood this? Let me know. Okay, just let me know how many of you are facing difficulty in this. कोई तो होगा. You can just let me know. There is no problem in this. Okay, great. Now let's just move to um, this question. So what this question is saying, let's suppose this P and V1, V2, V3, these three things are given. Find a basis such that this is a change of coordinate matrix. Okay. And these two are asking. So can you do this as a homework? I think answer is on the next page. It should be easy question. Okay. Just try it as a homework. So P is change of basis matrix. Find a basis U. Okay. Interestingly, they are asking, this is little reverse question. They're asking the basis itself. They have given the change of basis matrix. Okay. They're asking the basis itself. Okay. Just try this question. Should be okay to everyone, right? Can I give this as a homework? I mean, answer is actually there on the next page. You can just try and just see if your answer is matching. Okay. Okay. Now let's just see this question, or this question is saying. So it is little lengthy, I think, but yeah, let's just read out it. So what they're saying, change of bases for Rn and subspace of Rn, coordinates of vector in a given basis as well as relationship. Okay, let's just see. Compute the coordinate transformation matrix for this basis. That is, compute the matrix W such that that can transform to this coordinate. Okay. So what it should be from any standard basis. Okay, from any standard basis where this is continuing, y is in the basis B. Uh, the vector containing the coordinates of y in the basis B, then that gives the. Okay. So from any standard basis, let's suppose 1, 2, 3. If you want to convert to this basis, then you will be multiplying by B or B inverse. From standard basis, if you want to convert to this, then standard basis to B, then B inverse, right? Okay. So I think the B inverse is answer. W equal to B inverse. And what is the next paragraph saying? Let's suppose B1, B2 is given. Compute the coordination transformation matrix C. Okay, such that this. Let's just read out this. Maybe I can go to the next page and just zoom it out that what they're trying to say, right? So yeah, by the way, this W is just B inverse. Now let's just check what they're trying to say for this next question. So they are saying that there is a matrix C such that Y in B2, Y in B1. So what the C is doing? Converting from B1 to B2. So what is the C? Can anyone tell me? What should be the C? Converting from B1 to B2. So I think it is B2 inverse B1, right? Okay. So this is the answer. Okay, it was easy question. Anyway. Now let's just solve this question, which I have taken from MIT. Okay. Let's just solve this question, what they're saying. So they are saying that let T be some linear transformation, something like this. Find T of 0, 1. Maybe I can go to the next page and I can just zoom this. Okay. Okay. Just let me know if you are able to do this. Just try it out and let me know if you're able to do this. And those who did it, you can just tell your approach that how you did it. And also, if you want, you can just try this B and C. Okay, this option, this B and C also. Okay, so if you're done with the A, then just try B and C also. Okay, so let's just see, right? That what is the answer? Okay, let's see one by one. So this t of 0, 1, right? This t of 0, 1, they're asking, they have given the transformation of, of some basis vectors, but they are not standard basis. I mean, this completely, it is not a standard basis, right? But if they've given the transformation in some other basis, probably let's not worry about it. Then can you find out some other transformation? Yes, you need to represent this 0, 1 in terms of these bases. So what is this 0, 1? I think it is 1, 1 minus 1, 0. It is very straightforward, right? Okay. So you can take t of this, both side. Okay. Just a second. So, so t of this both side, and then you can find out the answer, right? Which is minus 10 plus 4 will be, I think, minus 6, 8 minus 3, 5, right? So minus 6, 5 should be the answer. Okay. Let's just check. Yeah, minus 3, 5, minus 6, 5. Okay. Is this okay to everyone? Okay. Now, what they are saying that what is the matrix A representing T in terms of the standard basis vectors? This is used for the input and output. So input and output is same. Then they're asking A that does the transformation. Okay, so what is the answer? So maybe I can just tell you that what they're asking is, see, this is okay, right? Okay, now let's just see. They're asking with respect to standard basis actually. Isn't it easy? With respect to standard basis, with respect to any basis as you know, right? So this is the answer, right? I mean, here you need to write S1, sorry, S with respect to standard basis, but with respect to standard basis, even if you don't write, then I think this is the matrix, right? So tell me, do you have even E2, T of even, T of E2? I think you have it, right? So what is T of even? This is nothing but 1, 0. I think this is minus 4 and 3. This is minus 6 and 5, right? I mean, this 0, 1, minus 6 and 5, that is what we have just got. So minus 4 and 3, minus 6 and 5, right? Okay. Now let's just see option C. What is the matrix B expressing T in terms of basis consisting of the eigenvector A? What is the matrix B expressing T in terms of basis consisting eigenvectors of A? Okay, the same basis is used for the input. So basically, you can find out the eigenvectors of A. Maybe let me just tell you the eigenvectors of A. Eigenvalues are this. Okay, so you can find out the eigenvectors of A, and then you can solve this question, right? And again, we will actually resolve this question later on in the diagonalization. Okay, we will resolve this question later on. Can you observe that this is a diagonal matrix, right? This is a diagonal matrix. So this is also related to diagonal matrix. I mean diagonalization. We will resolve it later on also. Okay. For now, you can find out the eigenvectors and you can solve this question. Okay. But we will do it later on also because this is something related to diagonalization. Okay. And that's where all of this will get connected. Okay. So this is one question which you can do as an homework. This is a good question. The answer is on the next page. Okay. Answer is on the next page. You can do this question. I mean, this is actually the good question. If you want, we can do it here also. But I want you to try. Okay. This is actually a good question. Easy also. I mean, it's not very tough. Answer is on the next page. Okay. Now, should we start this new topic today or maybe tomorrow? So currently, I don't have much here. I have the definition of the similar matrices. Okay. And just one or two properties to prove. And then that's all. Right. Okay. So let's do one thing. We can start this new topic tomorrow, which is the similar matrices and the diagonalization. Okay. Cool. So thank you everyone. Thank you so much for joining in. Thank you. You can just let me know if the the lectures are slow, Do you think the lectures are slow? We have spent, much time in just understanding linear transformation and change of basis, and now we are moving to regularization. Do you think it is slow or something like that? Okay, so Shreyas is asking, hello sir, new live lectures are for DA or I have to watch recorded also? No, you have to follow from module one, recorded, and then you can watch the live lectures. You have to follow from the recorded one, module one, and then module two. Okay, okay. Thank you, everyone. Take care. Bye bye.